Hello, my name is Jonathan Varner, and I'm a product manager with AutoForm. I'm here with Bill Pittman. We've had previous talks with Bill on some of his blog articles and his take from his experience in the industry. If you could, Bill, go ahead and introduce yourself.
Sure. I'm Bill Pittman, president of Feasible Forming Solutions. My previous roles were manufacturing feasibility engineer for major OEM, actually two of them, and prior to that, Tier 1 supplier, and I have a die making background as well.
So those previous interviews that I've talked about dealt with the blog that Bill had expressed four main pitfalls to dealing with stamping simulation development. In the first interview, we kind of went over the first two primarily. The first one was working without simulation proof, and the second one was dealing with looking or thinking about the whole picture, not just individual parts, individual problems. So we're going to expand on that a little bit today and go to the next two. The first one that we're going to talk about deals with unsatisfactory tryout conditions as part of the development cycle. And then the second one deals with correlation of simulation results. So Bill, could you give us a little bit of a summary of what you mean by the tryout kind of situation being a problem or being a benefit, maybe both?
Sure. So in simulation, I always say I have the perfect die, the perfect press. So that's not very often the case when you get to the physical tool. It's critical that your die conditions match your simulation model. So if, here's an example, I was in a tryout event that I came down and they're saying the part isn't forming like you planned. And it's like, okay, so I stood in front of the press and looked around, and there was actually no pressure system at one end of the die. And it's critical to be able to control that material. So, I said, time out, we're going to need the pressure system under this end of the die to move forward. And ultimately, they ended up having to rework the die, and it did come back and worked according to plan.
So again, simulate what's going to be built, and you have to build what was simulated.
Exactly.
For those two things to match.
Exactly.
So what about the topics of like spotting or maybe other tasks that go along with the tryout, blank size, those kind of things?
Sure. So spotting is key. And, from the other side of the scope, if you're a die maker or a die build vendor, spotting equals a lot of money, a lot of time and hours, and so naturally your goal is to get the die bought off in the shorter amount of time. But spotting is key, and I've seen many times where it wasn't there. And in fact, I had one where it was a dash panel, and through simulation we actually did some creative stuff and had some relaxed bearing in one area and then better holding in another to try and feed a large geometry. And when I got to the die show, actually they had it reversed. The spotting was hard in the area I wanted relaxed, and laxed in where I needed it held. And again, once we matched the planned conditions from simulation, the panel performed, and we were able to buy it off.
Okay, and that story kind of plays into the correlation side of things.
Yeah.
You have to simulate what will be built, and vice versa. You have to build what was simulated. If those two things were initially done together or done with respect to each other, to achieve the desired outcome. So your last point is having this correlation as part of your experience or knowledge as you're doing simulation, right?
Yes, absolutely. So correlation is key. You have to be able to replicate what you planned or have simulated in the press. So unfortunately, some organizations are structured a little differently, where the simulation is a separate group from the die follow-up group and the die design group. So if your organization's set up with silos like that, the simulation guys, their goal is to have a green simulation and hand it off. Whereas if they can't correlate what they've done, that activity is actually more harmful than good sometimes. Yeah. So it's key to have that holistic approach and be able to validate exactly what you're doing. I've always said that, simulation is actually cost avoidance. That's its biggest value.
Yeah, that's a good way of looking at it.
Yeah.
So. Well, I think that covers, we'll say, the 4 pitfalls in a kind of very brief way. If you don't know Bill, if you're not familiar with him, check him out on LinkedIn, as well as myself. But I appreciate your time, Bill, and your experience, and hopefully we get to talk again sometime in the future.
Sure. Sounds good. Thanks.
Thank you.